Dr. Eleanor Drage, the host of the Good Robot podcast. Join me as I ask the experts, what is good technology? Is it even possible? And how can feminism and other justice-seeking movements help us work towards it? If you want to learn more about today's topic, there's a full transcript of the episode at thegoodrobot.co.uk, along with an especially curated reading list by every guest. I love hearing from listeners, so feel free to reach out on Instagram, TikTok, LinkedIn, or through my Cambridge email address. And don't forget to leave a review on whichever platform you're listening from. But for now, sit back, relax, and enjoy the episode. In this episode, I talk to the incredible Elisabetta Matsumoto, a professor in the School of Physics at the Georgia Institute of Technology. She uses really cool geometry to understand the mechanical properties of materials, like how smocking patterns can help prevent organ prolapse after pelvic floor surgeries by making the pelvic tissue stronger and stretchier. This is such a great episode on the intersection of feminized crafts, maths, and technology, and I hope you enjoy the show. Thank you so much for joining us today on The Good Robot. Kerry is not here today, so it's just going to be me, but I'm very excited to have you. Can you introduce yourself and tell everyone what brings you to the topic of gender, feminism, and technology?
Hi, Eleanor. It is absolutely a delight to be here. So I am Dr. Elisabetta Matsumoto, and I am a physicist who studies textiles. So I'm really interested in looking at the ways in which making textiles from a hand-making point of view sort of lends themselves to understanding mechanical properties. So one thing we might ask is, why is your t-shirt stretchy? Or can I make a fabric with a custom response?
Very cool. And we'll be talking about fabrics and craft and all these things that me and I love so much a bit later on. I first wanted to ask you this big question that we ask all our guests that tends to be very difficult to answer. So what is good technology? And perhaps you can respond from the perspective of somebody who works with textile as a technology. And how can it help us? What does good technology look like? And how can we work towards it using craft and textile and knitting?
So that's a very hard question. Good technology, I guess, is technology that sort of helps humans out. And so this was something that we obviously needed to clothe ourselves. So things that helped us make fabric, so looms starting off. And now that we have mechanical looms, which I guess the Industrial Revolution helped make into an industry, both good and bad, gave rise to us being able to buy fabric. And now we use sewing machines to put that together, which is amazing. But now also we have problems of cheap labor and a workforce that we're not respecting. So I think the thing with textiles is that, things that help us connect to them are also unfortunately things that are used to create also capitalism. So there's a little bit of good and a little bit of bad in pretty much every technology that we've come up with.
That's perfect. Okay. I think what I wanted to go on to ask you next is about how knitting has been disavowed in masculinist computer science for such a long time. And I love something that a collaborator of mine said recently, Felienne Hermans, who's a feminist programming language designer. And she said that knowing programming language is one of the biggest gifts you can have next to knitting. I love the sort of having those two things together. And knitting and computer science have had this long history. And Judy Wackman, who's a sociologist of computer science, showed us these cartoons from the 80s. They were trying to get more women into computer science. And these cartoons, and contact me if you're listening and you want to have a look at them, say, if you can knit, you can sew. And they're from Micro Sister. So as a physicist, can you tell us, why do you love knitting? And what can geometry gain from this kind of exploration of what you call the topology of soft materials? So maybe you can explain what a topology of soft materials is. And also just from you, from the heart, what is it about knitting that you really enjoy?
Yeah, so I absolutely love knitting. So I definitely came to knitting well before I came into physics and anything computer science related, but I definitely really resonate with the comment about uh programming being a really wonderful gift apart from knitting. But I think to me, I kind of view it more that knitting is a type of a programming language, but you're not telling a computer what to do, using your fingers to tell fabric what to do. So it seems like every stitch you take is really like encoding like a word or a letter or a piece of like code directly into the material. And as you continue to make your piece, you can start to see how those bits of code work together to make an object. So you can sort of start with like almost a simple like hello world style program, which would be like a garter stitch is just knitting, and then you flip it and then you knit and then you flip it and you knit. It's the first thing you would learn. But at some point, you might learn how to do increases and decreases, and you can learn how to make things like lace. And for me, like making lace was really this very visual connection between the stitches you're making, the sort of code you're writing, and the final product. So you can often sort of feel like you're following a recipe and not really knowing what's going to happen. And then after a while, you're suddenly seeing like things coming off your needles that look like leaves or flowers or things like that that sort of come out of it. And then as you do it, you kind of learn what the logic is of like the combinations of stitches that build up a different set of shapes and a different sort of texture of your piece.
It's so beautiful. It reminds me of, I have some pieces by a designer in Berlin, Kasia something, I need to remember her name, but she makes latex designs out of 18th century lace patterns. And even though like the difference in material it has a totally different effect, right? But you still have that kind of, there's something of the design there that feels traditional, even in this very untraditional fabric, I guess. So what does the material matter then? Whether you're making lace or you're creating code, is the difference then a question of the materials that you use rather than the way that you're making whatever it is that you're creating?
Yeah, I would argue that the code part of it is like what stitches you take and not the material you take them in. So there's something sort of universal, whether I would be using a woolen yarn or if someone is, I don't know, knitting with an LED strip or something like that. You're still basically doing the same things and you're encoding the same program. But, I guess it's like, is it I don't know, a Python code or is it a C++ code? Maybe that it has a different feel to it because it's coming from a different place, but it's still executing the same function in a way. But that's really cool that she's combining those materials. I love mixed media things.
It is. It really is, and it shows how you can pull something from one era and make it new. The other thing I quite like about the pieces, but also about knitting in general or sewing in general, is that it's very intuitive. Perhaps in a way that coding isn't, although maybe that's arguable. In knitting, knowledge is passed down through generations of hand knitters. That tends to be where the knowledge is, right? Is that true? Do you think knitting is more intuitive than coding?
I think intuition comes from maybe a different place. So, I mean, if you have learned from, your mother or your grandmother or even a male relative, I mean, I guess that's less common, but certainly there's definitely plenty of men who knit. So I don't want to, exclude them. But learning from a person has a very different feel to it. So you learn their intuition and you learn what mistakes do before you've made those mistakes sometimes. And you sort of learn rules of thumb or you learn different shortcuts. So there's this historical lineage to what you learn. So the things that my mother would have taught me are very similar to things that your mother would have taught you, but they will have been filtered through my mother's experience and your mother's experience. And I think part of that is that lives in the textiles we make. There's a lot of experience that just comes in being able to touch them and having crafted something. There's a slightly, I don't know, people really, really like things that they've touched or can touch. And also things that they've made is really important. So I think in some senses, like textiles and craft in general has a really intuitive aspect to it on one hand, but other people might feel the same way about coding, that it's, it's very neat. It lives in, a couple of documents on your computer. Like it's a different aesthetic. And there's also lots and lots of different ways of thinking about coding languages. So you can think of, the ones where you type everything out in some sort of language, or there's the ones where you have little boxes and you draw wires in between them. And, they do the same thing, but they feel very different. Like personally, I can't stand the ones that you pull wires in between. I need to have the text to document, but that's just a personal choice. So someone might like knitting, someone else might like crochet or lace making or, pottery or something like that.
And these different modes of creating pattern, I guess, appeal to different kinds of people, different kinds of brains, or potentially, depending on whether you've been encouraged to do craft or encouraged to do code, people express that desire to create, to pattern the world in a particular way according to, what they've been encouraged to do. I'd love for you to tell us a little bit more about the way that your work influences manufacturing. And it might seem incredible to think that craft and manufacture, that experimental crafts is improving the way that we do manufacturing. Can you tell us a bit more about that?
Yeah, so manufacturing is such a complicated thing to think about. I mean, we have supply chains starting from, people picking cotton or people taking petroleum refined chemicals and turning them into fabric. And then those get spun into thread and woven or knitted into fabric, and then the fabric gets chopped up and sewn into garments, and then the garments get sold to us in industry. And I'm sure I've skipped about 1,000 steps in that process. So I think if we're thinking about manufacturing, we can kind of think about like almost any point of view. So the point of view that we started with, and definitely are hopefully not going to end there, but we started by thinking about how people would hand knit something like a sweater. And so people often will make different types of stitches in different places for reasons of having different mechanical properties. So you might have ribbing near the cuffs and collar. Some places you might use what's called seed stitch to make it a sort of bit more isotropic so it doesn't stretch too much in only one direction. And these are things that people would have done from an intuitive point of view, but also because they start with one type of yarn and knit the whole garment from one type of yarn. And in industry, often instead of using the combination of stitches, what we would call a topology, they tend to combine lots of different fibers together. So you might have elastane, which is what spandex and lycra are made from. You might have polyester, you might have cottons and wools, you have so many different things, and they blend them together in very specific proportions, but keep the stitch pattern, the topology of it, all the same. So in the code analogy, it's maybe not quite the hello world, but it's maybe one more program after that that's giving the sort of fabric its bulk structure. So we're interested in saying, well, instead of those specific yarns, what can we do on the stitch pattern side? Can we emulate the results that you are going for, but by modulating what the stitches are rather than the material itself? So that's what we're sort of interested in from a manufacturing point of view. And that leads to less waste from petrochemicals, but also I think a thing that's really fun to think about from textiles, particularly knits, is that you can knit garments, like the flat pieces of garments, with zero waste. You can knit out just the shape of the pattern pieces you want. Or some machines, if you've got a really fancy machine, you can just take the whole garment and knit out the entire garment. And so that means that there's no waste from the patterning process, from cutting and sewing things together as well.
So is it that you're using one bit of fabric, but because you're sewing it in a particular way, you're just using that one bit of fabric? As a, I'm not as a
Yeah.
non-knitter, I don't have to explain.
So maybe I could say if I were sewing myself a cardigan,
Hmm.
say, I would have made, I guess, 5 parts. So I would have a back shape, a left front, a right front, and 2 sleeves. And when you're doing the knitting, you have the shape of each of those pieces already built into the object. So I would have the place where my armhole starts and the sleeve joins in. I'd have the place where the top of the sleeve meets my shoulder. And these are all sort of geometric parts of this that would exist only on their own. Whereas if I were sewing, I would take a large flat piece of fabric and then cut out those shapes. And so there's only so well you can smush those shapes together into a piece of fabric. And there's always going to be waste left over.
Not only are you transforming sustainable clothing, but you're also making waves in medicine. And I know that you're doing incredible collaborations, for example, using smocking to reenact surgeries for pelvic organ prolapse. Can you tell us what that is and what you're doing to resolve it?
Yeah, so this is a project that we are absolutely so excited to work on right now. So we were approached by some pelvic surgeons from Emory, so Dr. Robert Kelly and Dr. Natalia Calzada Jorge. And so they deal with reconstructive surgery on pelvic floor dysfunction. And this is such a hugely common problem, something between uh, 25 and 50% of people with uteruses will experience this at some point in their life, most commonly either after childbirth or with age, particularly. Has some genetic components to it, but when pelvic floor dysfunction becomes bad, you can end up with some of your internal organs protruding through into your vagina or your bowel. And this is incredibly uncomfortable. It makes daily life really, really, really challenging for a lot of people. And so there's different surgeries that are designed to sort of strengthen the pelvic floor and the walls in between those organs. And I guess there's a traditional surgery that involves kind of making almost a sort of billfold and sewing it up. That was invented over 100 years ago, and it does definitely improve people's quality of life, but something about the surgery makes it almost heal too well. So it sort of heals to the point of going back to the sort of tissue it was before. And then I think in the 70s or 80s, there were some manufacturers of people who were solving or doing meshes for hernias. And they were saying, oh, what is pelvic organ prolapse but a hernia of the vagina? Let's, put this mesh there. And that, of course, got rushed through a lot of regulatory services. And a huge number of surgeries using a vaginal mesh happened. And a vagina is not the same as your lower abdomen. I hope I do not need to mention this to any of your listeners, but that had a lot of problems related to scar tissue forming, loss of muscle tone, and led to a number of lawsuits. So this is a surgery that I guess can happen in certain cases, but is very problematic. So the idea that the surgeons had was sort of coming up with a new technique with sutures that would enable us to create sort of a stronger pelvic floor, but just out of your own tissue using a natural healing process. And so we took inspiration from smocking. So this is a embroidery technique that's existed at least to the Middle Ages. There's pictures of people using smocked garments. And smocking basically is an embroidery technique that is used to give some amount of elasticity to woven fabric. So woven fabrics, particularly ones made out of cotton, linen, wool, and natural fibers, do not have a lot of stretch to them. But by making stitches in a specific pattern, you can allow those fabrics to have some sort of stretch. And so this was used in any number of garments from, a tunic might have the cuffs and like the cuffs around the wrists and a neckline that were smocked. And that would definitely make it easier to use a garment as someone is growing. So when I was a child, my mom made me a smocked dress, which I think lasted me from when I was about 2 till when I was about 8, just because of the amount of elasticity it has. So the idea was to repurpose some of the ideas from this embroidery technique and try to see about using them to improve the outcomes with pelvic surgery. So we're nowhere near there, but we're exploring, trying to see how much additional strength we can impart into a fabric by varying the smocking pattern.
So is the idea that this smocking is a fabric that's used internally, or is it?
No, we actually want to take the stitches directly into the pelvic fascia. So we're using the same smocking-like stitches used the way sutures would be normally taken place. So you would create the new stretch out of the original pelvic tissue. So you'd just be encouraging it to heal in a way that has a little bit more mechanical support than it did before.
That's fascinating. So you're actually, through the changing the way the stitching is done, changing the properties of the organic material that we have.
That's the goal. We don't know if it's going to work yet, but I'm so excited to think of, this historical sort of embroidery thing being able to help modern women. I just kind of love the women helping women through women's technology gist of it. But I will also say that the team of 5 people currently has 2 people who identify as women and 3 people who identify as men. So we are not a monolithic team of scientists.
That's okay. Men can do smocking too. It's allowed. It's good. Smocking also is one of those fabrics that is coming back into fashion. And it's interesting how it's not just the idea that, knitting is a women's art, but also the different materials themselves that come in and out of fashion seem a bit antiquated. I think smocking, right, was also for pajamas, nightwear, but also for, like, women's undergarments. Is that correct?
I'm not 100% sure about that. I guess I've seen some paintings and sort of etchings of it from the Middle Ages, but I actually don't know the recent modern history of it. I should probably read up on that.
I'm pretty sure that I had a smocked dress that had that kind of stretchy thing in the middle of the chest.
Yes, it's very common in anything for
girls.
It's like the one size fits all things that you can often buy at like craft fairs and things like that, because it will stretch to fit any chest size.
Which is very sustainable, and actually, like, just looking on the internet now, smocked, I don't know what to call it. I mean, it is a smock, it's not a dress, are seen on men of all varietals. And if you have a look online, it's a garment that you would associate with women, but definitely is something that men have worn for a long time, and interestingly became feminized, I guess. It's the kind of outfit that you might not imagine a man to wear today.
Fashion is fascinating.
Isn't it? I was watching, I was reading yesterday about how in the 15th century, pink was worn originally by men. It came from Bois de Brazil, and it was definitively a male color. And it wasn't until much later that it became feminized. And now we think of pink and blue as has always been a binary that associates itself with gender, right? Yeah.
Yellow and green are the best baby colors, because then the baby can decide once they get old enough.
Right. Exactly. I'll be doing that. I wanted to just end by asking you about ambiguity, because, well, going back to what you said, that knitting is a kind of coding. It's not just analogous with code. It is a form of coding. And it's one that allows for a lot of ambiguity and loose interpretation, unlike a lot of programming languages that are binary, so yes or no, and there's not much there's not much ambiguity in programming languages. So one of the things that Felienne, who I mentioned, is really concerned about is how can we create programming languages that allow the people who write them not to have to make a decision at the moment that they're writing it, but to leave doubt within the programming language. And is there a way that we can look to knitting patterns to inject more doubt and ambiguity and context specific adaptation, so adapting programming languages for different uses? How can we look to knitting to create more of that?
Oh, I love that idea. Thinking about context specific programming is really fascinating. It'd be really interesting to see ways of making computers sort of flexible at interpretation the same way that humans and animals are able to think about things in different contexts. I think fabrics, and I know knitting better, so I'll use knitting as the analogy, have a fantastic way of doing just this. I mean, for knits, it's probably primarily mechanical, although there's plenty of people who will knit with wires and create circuits just built into the garments. But from a just purely mechanical point of view, there's lots of patterns that would have, I guess we would call them metastable states. So it can have one conformation in one context and be perfectly happy, and then another conformation in another context and also be perfectly happy. And then being able to get in between those requires some process of mechanically moving the fabric around. So this could be something like putting on and taking off a garment. You might be able to have it encode something. I mean, even, I guess, if we put something on and take it off and it's inside out, that's already doing some amount of processing that's recording something about the two states of inside and right side out. But for this sort of context specific programming, if you'd want it to sort of return information, so I guess an example of this would be something like a strain sensor. So you can imagine that once it reaches an amount of extension, it triggers, I don't know, an electronic signal that gets recorded somewhere. I guess you could imagine using this for something like a compression stocking. Like after a certain point, the signal turns off and you've got enough tension on your stockings, but if it slides down, you get a signal that says, pull up your stockings. So you can imagine something like that being, I mean, that's not exactly context specific because that's designed specifically for stockings, but maybe there would be a garment where you could use that for stockings, but you could also use it to, I don't know, measure the size of a pregnant woman's bump or something like that, and use that as a way to signal, I don't know, something about garment change or needing to see a doctor or whatnot.
Cool. What's nice about that is it's a low technology, in inverted commas. It doesn't require power. It can be done by anyone, and hence it's probably not used. We know that a
Yeah.
lot of the reasons that AI has become masculinized is because it's deemed to be hard. These other technologies like knitting deemed to be easy, or you could do it anyway. You can do it on the go in a way that, it doesn't require a huge data center or loads of power, loads of energy.
I
But it'd
would
be nice to
challenge
see.
Elon Musk to learn how to knit.
Right, exactly. But sustainability is forcing us, requiring us to find other ways of building technologies. And some of the most exciting things that I've seen is innovations in AI have been innovations for low resource scenarios, like microscopes that can be put together using 3D printed bits of materials and can be used all over the world, equally sort of solar powered sensors and that kind of thing. And I think that this sort of ingenuity to me is really exciting. Those are the innovations that I'm really thrilled about, not just things that require us to dig up vast waves of lithium and quartz.
Yeah, I think it's really fascinating also that thinking about the like lo-fi tech is also very democratizing because, it's not just that tech is hard, but it's also expensive, which makes it an elitist structure as well as it makes it masculinizing structure. So if we are able to have, microscopes that we can take anywhere, I think a lot of what's overlooked also is that I think every indigenous culture has come up with their own forms of textiles and crafts. And, they're very, very smartly used in terms of like building things for both form and function. And we have basically come in as sort of a Western society and been like this, yes, that, no. But I think we've probably lost just so many solutions to problems by not listening to the technology that people have developed for centuries in their own communities all around the world.
So thank you so much for joining me today and talking about all these incredibly interesting things. We will have a reading list to go with the show, and if you check it out, it will have some things that we've talked about today. But thank you so much, Sveta.
Thank you, Eleanor. It's been an absolute delight.
This episode was made possible thanks to Stiftung Mercator and the Leverhulme Trust. It was written and produced by me, Dr. Eleanor Drage, and the editor of this week's episode is credited in the episode's description. Thanks for listening.